What is the best interpretation of the integral antiderivative capital F of x equals the integral from a to x of f of t? Well, the antiderivative gives you the area under a curve from 0 to x, which is the answer B. Okay, so this is just basically a very initial definition of what the integral does for us, and the integral gives us the area under the curve. Capital F is the antiderivative notation. And that's what you do for this one, short and sweet. If g of x equals the integral from 2 to x of 3t squared minus 4t dt, what is g prime of x? Well, the fundamental theorem of calculus states that a capital G of x would equal the integral of whatever this is. I guess we can call it from a to x of f of t dt. So that's what this is. Now, if this is g of x, if we're calling it lowercase g of x, then fine, I'll call it lowercase g of x, whatever. But taking the derivative of it essentially has me take away the integral. And what I'm going to be left with is I'm going to be left with, instead of 2 to x, I'm going to be left with the exact equation that I started out with, but with x's instead. That guy right there. So the answer is going to be A. Fundamental theorem of calculus. Kind of useless, but it's there. If h of x equals the integral from 1 to x of 2x plus 3 dt, what is h prime of x? Well, we're going to use the fundamental theorem of calculus here. And the fundamental theorem of calculus states that if I were to have the antiderivative, that's going to be the exact same thing as the derivative from sum a to x of f of x dx, right? Well, they're calling it lowercase h, so fine, let's call it lowercase h. But if I were to take the derivative of that, let me write it out. If I were to take the derivative of that, that essentially cancels out the integral. And what I'm left with is 2t plus 3, and instead of t's, I have x's because I'm using of x. So 2x plus 3 is going to be A.